logging in back. All right, so we can continue from where we stopped. So I was asking, do we have any question on the 7 layers of the OSI? Do we have questions? Anything that is not clear on the 7 layers of the OSI? Do you have any question? Application, presentation, session, transportation network to the data link to physical. Is there anything there that is not clear? If you have questions, please try and ask. Right. So I want it to be as understandable as possible. That's why I decided to use, also pictorial, show some pictures so that we know that these are things that we relate with. It's not a big deal at all. So different type of network, we talk about it. So you have local area network, all right, network within a particular, environment, but within a particular environment, building, for example, all right, network within the building, all right. So you have to look at the connection point. Are you going to use wireless? Are you going to use wired? All right. Security-wise, wired are more secured than wireless, obviously. Even the wired also have different level of security. Like, for example, optical fiber is far, far more secure than the UTP that we use in our office. It's far, far more secure. So why are we not using quasi optical fiber within office environments? All right, it's too expensive. That's the truth. And it's more difficult to handle. You need specialists, it can break easily. So it's like, it's like wasting resources, right? For you to lay optical fiber within just the building, you are spending so much, and there may be losses during the installation, all right? So it's going to be cost effective, even though it has security, it might not be cost effective. So that's why we are using untreated two-step pair, then have additional security. So you need to look at the appropriate cable, look at security, look at costs, look at the kind of transmission you do, all right? Look at performance issues, all right? I talk about that, UDP versus TCP. Which one are you going to use? It depends. So it depends on the scenario. Don't go and use UDP in a financial environment where you want to do financial transmission. All right, UDP is going to be a minus in such an environment. Okay, so all those are some of the considerations we look at. Okay, when you want to set up a local area network. I've shown us a picture of UTP. We are familiar with it. It's our network cables in the office. All right, I've shown us a picture of the fiber optics, which is used for long distance. It's not subject to attenuation. I've explained what attenuation is, right? The signal is dropping with time, right? And it could be wireless, right? You can use infrared, you can use radio waves, okay? So for the two-step pair, they have different categories. So you have Cat5e, Cat6, Cat7. You may want to ask your IT people which of the cats version are they using. That cat simply means category. Don't mind, in IT, IT like to use big grammar, all right, acronyms. So if you just hear Cat6 as somebody outside IT, is one big word, is a lie. Cat6 simply means category 6. Cat7 means category 7. Cat5e means category 5e, right? So different grades, all right? Of course, all of them have their different features. So your company should ensure that they are buying certified cables from reputable suppliers and segment problems area with switches. All right. All right. Additional assurance should be provided that maximum cable lengths are not exceeded. I've explained the impact of cable length, right? All right, for transmission. Once you exceed 100 meters, all right, it means you will have started to lose signal attenuation. So you will need to have repeaters, right, to be able to boost. We call them repeaters or boosters, all right, to boost the transmission again. All right. Parallel run of cables over long distance to also be avoided, since the signals on one cable can interfere with signals on adjacent cables. So the cables too, they talk to one another. All right. So signal on one cable can affect the other one. All right. That's what they call crosstalk. All right. So you don't run parallel cables along long distances to avoid crosstalk. I'm talking about fiber optics used for long distance. All right. Very expensive, but very secure. Very, very secure. Okay. Like I said, it's very fragile. So you need experts to handle it. It's very fragile, can easily break. All right, we can also use radio systems for our transmission, right? Can use radio system. So you see radio masts all over the place to be able to share transmissions across different points. I think I have a little note on those waves, on those wireless. So you can see radio waves. They have the longest wavelengths in the electromagnetic spectrum. They are produced by making electrons vibrate in an antenna. They are used commonly for radio transmissions and in television stations. So you can see an example of a radio mast, right? They are omnidirectional in nature. They can travel in different directions. At low frequencies, they can penetrate solid objects. So they can move through walls, move through buildings at low frequencies. But note that if you are going to transmit at high frequencies, they will bounce off any solid objects in their path. That's what they call line of sight. So if you are going to transmit radio waves at high frequencies and there are buildings, there are skyscrapers between point radio mass 1 and radio mass 2 will lock, the transmission will not work. Because what does that mean is that the mass 1 will not be able to see mass 2. Everything you are transmitting will be bouncing back. That's one big risk with radio waves. So you have to know that you are going to transmit and there are buildings like mountains, there are structures, mountains, and so on in the line of sight. You have to transmit at low frequencies. If you transmit at high frequencies, we lock. All right, so frequency range 3 kilohertz to 1 gigahertz, all right, but poor security, right, because since it's in the air, it can be easily captured. Attenuation is high. I have to explain what attenuation is. Setup and usage costs are moderate, used in long distance communication. Some frequencies require government license to use to transmit. All right, so a little information about radio waves. Microwaves, what I will call microwaves, they are unidirectional in nature, so it's just one direction. At low frequencies, just like radio waves, they can penetrate solid objects in their way, and worse, at high frequencies, they too cannot. All right, they too cannot. Frequency range 1 gigahertz to 300 gigahertz. Attenuation is variable. So when it comes to weakening of signal, it's still better than radio waves. Moderate security, setup and usage costs are high. All right, some frequencies, just like radio waves, require government license to use. They use them in long distance communication. They are used a lot in satellite communications. All right, let me talk a little about satellite communications. Satellite communications uses ground stations to send and receive microwave signals between artificial satellites which are in orbit around the Earth. So what are satellites? Satellite is actually any object that can revolve around a planet as a satellite. A very good example of a satellite which is natural is the moon. The moon revolves around the Earth, right? In 365 days. That's where we get our lunar calendar, 365 days, right? The moon revolves around the planet, right? And that's how we get our day and night also, depending on the position of the moon in a particular day. So that's how we get our day and night. So from the idea of the moon, you know, whites, thinkers, so okay, if there is a natural satellite that is moving around the planet, can we create an artificial satellite? So from there, they got the idea. So they started creating their own artificial satellite, right? Which they launch into space, which is now also just like the moon. It's like following the moon or going after in front of the moon, revolving around our planet. And that's why don't be surprised where you are right now. Maybe they are watching you. That's not the truth, right? Because they are there, up there. So that's why they are using it in broadcast, right? That's why you see CNN, what is happening in Nigeria live within 30 minutes, already live on CNN. How are they doing it? It's satellite broadcasting, right? So it has so many applications, so many use cases. They use it in oil exploration, right? From the satellite, right? Satellite images, right? Can be able to determine whether there is crude oil somewhere. They use it in military, right? Espionage. So many applications of the satellite communication, right? So they are now sending artificial satellite object. Now, one good thing about satellite again is they use it in communication, right? So you are going to have an uplink, you're going to have a transponder, you're going to have a downlink. Look at the diagram. All right. So this is satellite, artificial satellite in space. This is the uplink. It's actually a ground station, right? The downlink is also a ground station. So the uplink is the ground station that want to send the message. The same message from the uplink to the satellites, right? The transporter here, the job of the transporter is now to kind of increase what is the word now? Amplifies the signal, right? Amplify the signal. That's the word. Just like we have our repeater, right? In line communication. So the uplink send the message. The uplink is a ground station, maybe in US, send message satellite. Satellite drop the message to another station, maybe in Nigeria or in Afghanistan. So that's the downlink. So the downlink is also the receiving ground station. So basically they use microwave to do this. I'm sure we understand that. I just decided to add these extra notes to boost our understanding of these wireless technologies. Okay, I believe that is clearer. All right, so we can use them. Of course, radio waves, for example, the weather can affect it, right? The weather, that's why you see that a lot of sometimes when it starts raining, right, you may, your DSTV goes off. I don't know, I'm sure you have noticed. Right. So most of these wireless, right, I think even satellites, the rain can affect it, weather can affect it. So once it starts raining, your DSTV, right? So that is the challenge with some of these wireless. That's why I say wired is more reliable than wireless any time till. All right. LAN topologies, all right, LAN topologies. How do you connect? How do you arrange your cables? Very important. So those are low-level networking stuff. I don't think they can ask that question at this stage now in the 21st century, Cisa. But it's good you know it, right? Networking arrangement. So you have bus arrangement. Bus arrangement is where you have a cable, a single cable connecting all your systems together. Just once, that's what they call the line topology or bus topology. The problem with that is that if that cable cuts, it's a single point of failure. The network is gone. Once the cable goes down, every device attached to the cable goes down. All right, you have the star topology, all right, which is most common. All the devices revolve around a single device, connected to a single device, like a switch or a hub. That's actually what happens in our office. It's actually a star, right? So you are using, all right, so all the nodes, all the endpoints are connected to a particular key component called a switch. Okay, so that one too, if the switch goes down, all right, it also means the end of the network. But you know, It has more security than just a cable, so it's more reliable than a bus. All right. A bus is a wire connected, so the wire can get cut. It's not easy for, most of the time the switch is not even somewhere where people can easily reach it, depending, right? Depending on the knowledge of the network people in the organization. I've seen an organization where you pass the switch as you are going to the reception, and I flagged it in that. It was an IT review. That this was for one organization some years ago in Lagos. I was shocked where they place their switch. Anybody A can reach it, which is not right. All right. So then you have ring. So all the systems, switch or whatever cable, everything is in form of a ring circle. All right. So that one is also not too advisable, because since everything is connected in form of a cycle, it means that if you want to add or remove a device from the network, you must disrupt the connection, because you must break that ring before you can add another system. And so while that ring is broken, the network is down. So that's why even the ring is rarely used. All right. Mesh is where you have multiple cables. You can have two systems connected with 3 cables. Imagine, instead of one. So you have like 5 systems connected with 50 cables. So B is connected 3 times, BC is connected 5 times. So it will be very difficult for that kind of network to go down because of the high level of redundancy. That's what they want us to know. All right. So most of the questions I've seen on these topologies is either on bus. Do you know that it's a single point of failure, or mesh? Do you know that it creates high availability, environment? All right. But I doubt if that kind of question will be asked at this time where we are right now. I've talked about repeaters, right? I've talked about the function of a repeater is to boost the signal. After 100 meters, you have attenuation, all right? So you have to boost it, all right? Similar to the repeater is the transponder that the satellite uses. I'm showing you, all right, that component also. So you have the uplink sending a message to the satellite up there. The satellite uses its transponder to amplify the message before sending it to the downlink, right? So we need repeaters and satellite transponders to make sure that signals are not weakened. All right, ops are what we used to use before the advent of switches. So if you want to connect to laptops, no problem. You just bring a network cable. I've shown you the network interface card, right? So you can easily just connect your network cable to your network interface card and connect the other end to the other system. The two systems are connected, they can start exchanging information, all right? But what about if you have 3 systems, 4 systems to connect? You can't use your cable. So those cables, of course, you use the cable, but you can't use cable to connect the 4 laptops, even 3. So what did you use? You use a switch. Initially, they were using hub, all right? But hub is not very advanced, not very intelligent, all right? So they have dumped it, all right? They have dumped it for a switch. I don't expect anybody to be asking questions on hub in 2023. All right? Then you have bridges, another component in the network. Bridges, what you need to learn to know about bridges is that they are store and forward devices. All right, so you have network A, it wants to send a message to network B. But at that point in time, something is happening in network B, a lot of processing are going on. So if network A drops that message, B will not even be able to process it. It might even be lost. So what does network B do? Luckily, network B has a bridge. It passes that message to the bridge. Bridge will hold it to store it. I will be checking for when network B will be ready to process that information. So the moment it determines that network B is ready to process the information, wow, it dumps it. Not before. All right. It is only when it is sure that network B is now ready to process that information. So you can see that kind of the importance of a device like that. That's why they call it store and forward. Please, this is important. It is examinable. All right. So it reduces collisions in the network where you have multiple messages being dumped for a network to process at a time. All right, which may be beyond the capacity of that network or that a particular device in the network. All right. So then we have switches, like I've said, also in the network. Job of a switch is to connect multiple devices, 3, 4, 5 systems with a printer and connect them with a switch. And so they are on layer 2. That's why they call them layer 2 switches. But I've told you, we learned about the OSI layer, today. So switches are also used to create virtual LAN, VLAN. So you have a single LAN, all right? In ISO 27001 Annex A, also in PCI DSS, it talk about network segmentation, very important. That is, like I come to visit you, right? Let's assume you are living maybe in a 3-bedroom flat. I come to visit you, all right? And luckily you have a guest restroom, all right? And maybe I'm just a distant friend. You have a guest restroom, you have your private restroom. So if I say, okay, please, I need to go to the restroom, where will you lead me to? You will lead me to the private restroom, right? Not your, you lead me to the guest restroom. Why? Because of segmentation within your building. So you have a private restroom, you have a guest restroom, you have a sitting room. Most likely as a visitor, I will not be given access to your kitchen, for example. You may bring food for me from your kitchen, but that does not mean I will have access to your kitchen. I will not. Why? Because even though I'm in your building, I'm in your house. Yes, I'm in your house, but you know that basically maybe like 80% of visitors to our house don't leave our sitting room. That's security. That's security, right? So that is exactly how it is in our houses, exactly how it is for networking. So even though I'm a staff, I'm working in HR, all right, that does not mean I should be able to see 100% of everything that is happening in, what is happening in finance, what is happening in audit, what is happening in business development. Once I log into the network, I can see everything. No, that's not security. So you have to be able to they call it network segregation. Switches can also be used to break. So it's like you are breaking a single network into sub-networks. That's what they call virtual LAN. Very important security, all right? So some switches too can also do other things, in our modern world, you are buying shoe. Instead of just ordinary shoe, they will tell you that this shoe you can wear it, all right? This shoe can help you to fly in certain environments. This shoe can, can warm your feet if it detects that your temperature is a bit low, So that is the kind of world we are today, where there's not a product is not coming to us as a single product anymore. So it has several features, all right? Exactly. So you can have a switch that can even perform security issues, or perform security role, can do encryption, can do decryption, can do what they call load balancer in networking. Reduce load. What is load? So you don't want a particular machine to be overwhelmed, or a device on the network, a node in the network to be overloaded. So what do? You introduce load balancers. Very important in networking. All right, very important in networking. I'm not saying we should be experts. We don't have to be experts in networking. You may choose to be a network auditor, which means you will go deeper than what we are discussing here. But that may not be your interest. But for you to function as an IT auditor, you need to be able to know all these things I'm talking about. All right, averagely, you should be able to have that knowledge to pass the exam, and even for you to be able to have, reasonable discussions. Maybe you are in a meeting, all right, and you are representing the IS audit department. These are, basic knowledge you are expected to have as an IS auditor. So you can have some switches that can work as load balancers. So they distribute the load so that a particular machine is not overwhelmed. Then we have routers. Like I said, switches are meant to be able to transmit information within the same network, the same local area network. But what about if I'm moving from Yahoo Mail network to Gmail? I'm transmitting between Union Bank, all right, and Unity Bank, two different networks. So we need routers. So they are the one that routes. That's the where they got the name from. So they route information from one network to another network. All right. We also have gateways. All right. A router can have gateway. Like I said, many of these devices come with multiple, 3-in-1, 2-in-1. All right. Buy one, get one free. All right. So a router can serve as a gateway. So a gateway is like a bodyguard in front of a network, right? So it can serve for security. You can have rules for a gateway. It's okay. Any traffic from another network that does not meet this rule, block it. So you see, so gateway can serve for security. They can also serve as protocol converters. What do you mean by that? The message that is coming from network one is not in the format that network B can process, even though that message is allowed. The message is allowed to enter our network, but it's not in a format we can process. All right. The gateway will change, convert it. All right. That acceptable message, it will convert it to a format the receiving network can process. Just like I was giving the example about the presentation layer. Somebody is speaking Chinese, right? But we don't understand Chinese. So what does the gateway do? It converts the Chinese to English that we can process. So that's another job of the gateway. It can convert protocols to that which the receiving network can be able to process. Then, like I said, it can also have security function. So that it can serve as our bouncer if there is need. General LAN security. I've talked about some of them. We need to have ownership. We need to have people that can make decisions. What is acceptable in the network, what is not acceptable in the network. All right, limiting access, least privilege. So even though I'm a staff, all right, or Parallels Bank, that does not mean I should have access to all the resources in Parallels Bank. So somebody should be able to limit what the access I will have to what I need, what my role is in the organization. There are some environments in IT that only selected people should be able to have access to that environment. There are some servers, very sensitive servers, critical servers, that may be like just 2-3 people. Sometimes maybe even just 2 people who have access to it directly. All right. Implementing record and file locking to prevent simultaneous updates. Okay. Enforcing authentication systems. Identify yourself. Enforce password rules, password strength rules, password lengths, password change, password formats. All those rules are very important in network environments. All right. Use switches to implement post security policies rather than hubs. Like I said, nobody is using hub. Or let me say, nobody that is security conscious will be using hub in these days and time. All right. So you can use MAC address filtering. All right. Like I said, you can use switches to implement MAC address filtering. So if you don't know the MAC address, block it. Encrypt your local traffic using IPsec protocol. All right. Some of these protocols are just for security. You can Google security protocols at the end of this class. Right. You see their list. Right. So there are some protocols that are for encryption. You can encrypt your network traffic. Right. Now, to gain a full understanding of what is happening in the network, you need to look at the network diagram. Ladies and gentlemen, this is key. right? In fact, that is the first thing you do in network audits. Please, this is important. The network diagram, network topology, that is the first thing you check. So looking at the network topology, you will see, so you have not even seen physically what they have. From the network diagram, you can look, okay, where is their firewall? Where is their IDS? All right, what kind of server, what kind of router are they using? All right, so from the firewall, is it a wireless environment? Is it a wired environment? What kind of connection cables are they using? All right, you will see all that in the network diagram. So the first thing in auditing a network environment is to ask for the network diagram. Very relevant especially in PCI DSS audits. All right, you want to see the network diagram, the current one. All right, you want to know who is the LAN administrator, what are its or her function, who are the users within the network, what are the computer applications used in the network, all right, what naming conventions are they using, all right, do they have policies, do they have a network security policy, and so on. These are areas of consideration. Then, of course, you have what we call a wide area network. I'm round up by 3:30. So, like I said, wide area network is multiple local area network. So, like I said, this meeting is a wide area network. All right, this meeting is a wide area network. So we have people from Southeast here, we have people from Lagos, we have people from Abuja in the class. All right. So basically, this is a wide area network. So we have a network that is combining devices, nodes across the country, nodes across the world. So data flow in one can be one way, simplex. What does that mean? It can only go one way, right? Maybe download, can only download, or you can only upload in that environment. That's what they call simplex. So that you are uploading or you are downloading. Half duplex means one way at a time. You cannot upload and download at the same time. You can either upload, after you are through with uploading, then you download. But you can't do both at the same time. That's half duplex. Full duplex means that I can download and upload at the same time. Sender can send message to the receiver, receiver can send message to the sender at the same time. Both of them can be doing that at the same time. That is what we mean by full duplex. And I've talked about communication line being either switch or dedicated. I'm sure you should be familiar with what that means by now. Dedicated, the line is reserved for that organization, very expensive or secure. Switch is not reserved for you, it's pay as you go, right? So that is what we mean by switch. Implementation of wide area network. How do we set up a wide area network? Most of the time, it will be a combination of wired and wireless. So I've said attenuation is very common with most wired cables, but we have a cable that is resistant to attenuation, and that cable is fiber optics. That's why in telecommunication, Glo, network, Airtel, you see all of them. When you look at the cables they are laying, you will not see UTP, you will not see coaxial cable. What you will see is optical fiber. Right? Main one, laying cables from Nigeria to Europe, laying cables from Nigeria to US physically. All right, it's fiber optics. It's fiber optics. There may be other type of cables, but why do they use other kind of cables again? Is because of maybe as backup, like we said in business continuity class. So, but they are backup just in case something happens to the primary cable. You want to look at other options, but your main cables are going to be fiber optics because they are mainly for long distance uh, 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 cabling. All right. Then we talk about microwave, all right, which we can use for the telecommunication. I mean, what's the satellite communication? Use microwave, right? But talking about the fact that climatic conditions, rainfall can affect all these wireless. Then I've also talked about the line of sight. line of sight. Once there is a building, once there is a structure, a mountain, a solid object, right? The transmission will bounce back, especially if it is high frequency. If the transmission is on high frequency, it will bounce back. But if it is low frequency, it will go through the buildings. Only God is just keeping us alive in this 21st century, because only God knows all these waves are going through our buildings, maybe even go through our bodies. Just God's mercy is keeping us alive. But it's just, you know, in the 21st century, we have to enjoy these technologies also. The technology also have its downside. God continue to protect us. So microwave radio, at low frequencies we go through structures, solid objects. At high frequencies, we just bounce back. All right, that is the limitation we have to be aware of. Then also climatic conditions can also affect this wireless, right? So that applies to satellite radio. I've mentioned the three components, right? You have the uplink, the ground station sending the message. You have the satellite itself, the transponder, which will receive from the uplink and amplify it, then send it to the ground station, which is called the downlink. All right. So, like microwave satellite signals can be affected by weather. All right. So these are options. All right. These are options that somebody implementing a wide area network can use to connect locations, connect branches, connect devices, all right, across a wide area network. So WAN devices now, right? Devices you will see in a wide area network, right? You will see a WAN switch, right? So, like I said, a wide area network is simply multiple local area networks working together. So within a local area network, you will still need a switch, is it not? Right? So you need switches to transmit within a local area network. Then of course, between the local area networks, you will still need a router. I've explained that. So routers are meant to help you to transmit from one local area network to another local area network within a wide area network. We have modem. I've talked about that also. Modulator, demodulator, especially when you are transferring across telephone lines. So it will help you to change digital transmission from a computer to an analog transmission on a telephone cable, then change the analog transmission on telephone cable back to digital transmission when it gets to the point of reception. That is the job of the modem, modulator. You see that also in a wide area network, and I'm sure you have one right beside you, right, as you're attending this class, right? So it's key aspect of key device that we use for wide area network. All right, you have access servers, right, which is to help us so that anybody that is not authorized cannot log into the wireless, to the WAN environment, either wired or wireless. There must be a server that somebody will have to log into, like an access point that you identify yourself before you can join the wide area network. Very, very important. Very, very important for authentication. All right. We have CSU, DSU. Now, let me show you the diagram of how that looks like. This is it. So you have this network. You want to send message to this network, right? So you can see this CSU, DSU is at so you have a transmission from here. It will go through the CSU, DSU here, pass through whatever technology they are using to connect these two sites together. Then the traffic goes through another CSU, DSU before it goes to this network. So this is Vancouver, this is Toronto. Now, CSU, DSU here is serving as output. So it's an output device here, but here is serving as an input device. Do you see? So it's an input-output device. Hence, a particular network starts another particular network. So it's the two CSU, DSU that is going to have handshake for the two local area networks to connect. Please, I hope that is clear. That's why I deliberately brought the picture here so that you can see, visualize it. and see how it works in real life. So this network is transmitting, Vancouver network is transmitting to Toronto network. There will be a CSU as a device, a physical device, actually a layer 1 device, all right, serving as output device for the network, the gateway, right? So the traffic goes through, right, then passes into another CSU, all right, before it now goes into the Toronto network. So you can see, so it serves as output for this network, serves as input for this particular network. That is what they use CSU GSU for. All right, it serves as input output, all right, device. So quite easy, quite easy. All right, you have multiplexers. Now, I also have a diagram of what a multiplexer does here. So you have multiple traffic, input 0, input 1, input 2, input 3, 4 traffic. Look at what a multiplexer will do. It will now merge all the 4 traffic into one and send that one traffic. You know, is it not easier? So like what we said here, you want to send from Vancouver to Toronto. Imagining this, we have like 10 traffic to transmit. To be more cumbersome, right? So instead of sending 10 traffic here, all right, maybe one by one, you can match the 10 traffic with a multiplexer into one. Then you send it at once. At the other hand, when it gets to Toronto, Toronto is going to have what we call a demultiplexer. So the demultiplexer will now break, you know, these outputs here. It will now reverse it. So it will reverse this single signal to 4 signals. Is that not interesting? So it makes our job, you know, transmission easier if we are using a multiplexer, the multiplexer. So you can have like 10 traffic, merge it into one, send that one. When it gets to where it is going, the multiplexer at the other side is going to reverse it. Simple. We have another one technology, all right? So one technology, we have what we call point-to-point protocol. What's point-to-point protocol? You can see the diagram here. All right, you can see the diagram. When you want to send a message from a point to another point, all right, it's not from a point to multiple points, just point to one point. You just use that technology. Point to point, you can see. All right, so this point to this point. Use point-to-point protocols, easy. It connects the 2 points. Connects the 2 points. So once you are sure, you're very sure, oh, this transmission is from this head office to regional office. Aha, simple. It's not head office to branches. Head office to regional office alone. Great. Just use a situation like that, you use point-to-point protocols to connect the 2 points together. Does it make sense? All right. So it's 3:30. I want us to stop here today. So normally we normally do 1 week on, 1 week off for the class A, all right? But we are very close to rounding up. So though I will still throw it open in the class, in the WhatsApp group, because I want us to continue to this domain 5 next week, if possible, if we can finish next week, so that we can free the class A. All right. So I will seek the indulgence of the class A members, so that we have this class next week. Hopefully, if it's not your what is it called, your NPR, right? I think it's better we try to just sacrifice and hold the class next week, so that we round up. I want us to round up this class of domain 5 next week. So Okay, the SQL. Okay, I talk about the SQL session. Okay, fine. So we can hold the SQL session 1 week after next week. Fine. So okay, I think that will do. Okay, so next week we continue with domain 5 for everybody. So then the upper week after that, we continue with the class B. Then so that will make the third week from now, third weekend from now, we can now do the SQL, which is going to be for everybody in the house also. All right. So please let's do that. Let's do that. Thank you for reminding me about the SQL class. So that will be 2 weeks after next weekend. All right. So so by the grace of God, we'll round up domain 5. We'll round up domain 5 next Saturday. We'll round up next Saturday. Right? The sessions are being recorded. Before the end of today, you get the recording. Please go over it, set it, try and pay your ISACA subscription fee, join ISACA, attend information security webinars, free, paid, there's no sacrifice, conference, all right, attend conferences, IT related, privacy, data security, all right. Then you must also have an area of specialization, all right. You must have an area. So you want to be a network auditor. You can't do everything. Though you must have knowledge of everything, right? Have little knowledge of everything, but you must have an area of IT where you are going to specialize. And what that means is that you are going to know what IT people know in that area. If you pick networking, you can talk network, all right, with an IT person at his level or high level. That's what that means. If you pick database, you can talk database management at the level of a database administrator. All right, that's what that means. All right, if you pick programming, that's another one. All right, application audit. It's okay. I want to be a Python specialist. I want to be a Java specialist. So, like, it's a big challenge. All right, it's a big challenge. So you have to pick an area. All right, but I don't want to scare us. Right? These things are not difficult. What is just need is attention. That's what I discovered. Is attention and commitment. It's attention and commitment. And there are areas that are not as technical. Once you are past your sister, all right, if you decide, okay, me, I don't want, if you can stay in some very easy waters and you will sell. Honestly, recently on LinkedIn, I was looking at people's profile, all right, I saw one lady that is very big, what is he talking about? Governance. And I was pitying myself. All right, why am I even stressing myself with all these hard technical issues that I'm always reading and reading and reading and studying and studying? This is somebody that, she just focus on GRC. All right, but I discovered that, we are built differently. Our callings are different. All right, so if you are called to deal with hard technical issues, you will find it, you find it fulfilling. All right, but it's not everybody that is caught for that. There are some people that, their own is compliance and they are flying there. All right, what they just need is little IT knowledge and they are good. That's why I don't want you to discourage yourself. I know that this thing is too hard for me. There are areas that you can position yourself and you'll be a global reference. All right, in information security, we have governance. All right, even management systems. There are some people, all right, they can close their eyes and talk about 27001. They can close their eyes and talk about COBIT. All right, COBIT is not technical, all right, but it's very key. All right, so there are some people like that. They can talk about governance, they can talk about risk management, they can talk about compliance. They are self, and you will fly as an individual. But we just need a little bit of some of these hard issues here and there and there and there. all right, to be able to, number one, to pass the exam, to be able to also operate in the office, add value to, you know, the organization we are working for, add value to ourselves. All right, but you need to pick an area or specialization. It could be data analytics. Anybody can do data analytics. All right. There are some people that after passing CISA, they just face ACL. There's nothing they cannot do with ACL. You are still an IS auditor. All right. Some people pick ACL, data analytics, and they're exceptionally good with it. Tableau. All right. Some people are very good with business intelligence. So there is, you can always just make sure you pass this exam first. All right. Pass this exam, then develop, you know, an area where you are going to be a reference, not just in Nigeria, globally. This field is a global field. All right. Become a reference. So God will help us, God will assist every one of us. It's been a good time. So please, let's see again, 10 a.m. on Saturday to round up domain 5. All right. Then the 2 weeks after that, we have our SQL class. Thank you. Have a nice, enjoy the rest of the weekend. Thank you.
Thank you so much, sir.
All right.